So Abishek, Kumar, and Utkarsh Srivastava join us today. Gents, do you want to say hi? You've got your
Hey,
microphones.
hello everybody. This is Abishek. I've been working as a software engineer in Layer 5, and it's been almost 3 years for me with Cloud Native and Kubernetes. And I've been working with Istio for the last 2 years. So that's about me. I'm looking forward for this workshop.
Yeah, hi guys. I'm Utkarsh, working as an intern at Calcote and as a open source contributor to Meshery too. Um, yeah, and that's pretty much about me. If you like blast us with questions in Slack or something, it will help you out.
So thank you, Tim. Tim pointed out my first mistake, which was, hey, I was talking about this URL in yellow and not sharing the screen. So already we're withholding, not good. But yeah, it's calcotestudios.com. It's just where I end up posting. Great.
I just published a post just to make more organized, to getting to know how far the audience is on their journey. So I launched a quick poll. So far, I'll leave it open for, let's say, 10 more seconds to get more answers. Let's see. We're having 16% of people who are completely new to Istio, 32% who have played with it but don't have it in production yet, and 50% who say they already have it in production. So
we're at the right conference. That's great.
So
thank you.
Let me share that. You should see those results.
Thank you for that, Pedro. That actually really helps. I realize it's occasionally unnerving for people to do so in a non-anonymous way. So this is great. And yeah, we are at the right, you're all at the right conference. If about half of you have got Istio in production. So this is fantastic. One other thing, so I spend my full-time focus in the open source community at Layer 5. There's, it's all meshy in there, I guess. There's a number of open source projects that we focus on in that community. If you want to get a hold of any of the three of us after this week, please join the Slack there. All of the service meshes are well represented, and a few other projects. So jump in. Okay, Pedro mentioned that there's a couple of prerequisites to the labs that we'll go through, to the workshop that we'll go through. First at bat is, well, it's Docker and Kubernetes. We will probably end up using them both. I shouldn't say probably. The labs take you through use of both. If for some reason you couldn't get a hold of Docker, we can probably work around that and just use Kubernetes. But Kubernetes will be a requirement. So it's a BYOK. It's a bring your own Kubernetes. Bring your own Kubernetes workshop. Good. I think hopefully everyone can see that we're, yeah, good. We're sharing. All right, of the requirements for Docker, by the way, I will be using Docker Desktop today. I think Abishek might be using Minikube, that's fine. Really, just about any Kubernetes environment is going to work for us. There's a couple of considerations depending upon which one you're using. We find that a lot of people are going between Docker Desktop, Minikube, Kind. Some of you might be running, have access to Kubernetes clusters from managed service providers, cloud providers. That's fine as well. The labs themselves, they will walk you through, they will make the assumption that you're using either Minikube or Docker Desktop for Kubernetes. It doesn't need to be, it can be a single node cluster, it can be small, it's fine. This is not the multi-cluster Kubernetes Istio workshop. So you'll hear it's not so important that if you don't have 4 gigs of extra memory to give to Docker, it's nice and you should if you have it. If you don't, this used to be really, we used to have a lot more trouble in earlier versions of Istio with making sure that there was enough memory on students, on attendees' systems. It's not quite as much the case anymore. So in terms of like what version of Kubernetes you need to have for the labs, you know, as long as you've got, well, yeah, as long as you've got 1.9 or higher, which I think we'd be hard pressed for, I think, anyone to be able to go find a version that old, you should be good. In 1.9, there were, that was when admission controllers and mutating webhooks were still, hadn't quite landed all the way. And we'll be using some of those today. Some of those terms are probably familiar to about half of you. For the other half, we're gonna walk through how sidecars get injected, how proxies get injected today. So we've got some obligatory introduction to what a service mesh generally is. We're not going to spend a whole ton of time here. I'll say this, that, well, there's a short book that I'd written. It was just, a second edition was just published about a month ago, about a month and a half ago. The Enterprise Path to Service Mesh Architectures. If this space is still new to you, it's a free report. I highly recommend the report. It's a short read, helpful, helps explain some things about why service meshes are here and how they compare and contrast to technologies that you probably already know. What value do they add in the face of a container orchestrator? What value do they add in the face of an API gateway? How are these things overlapping and how do they relate? We'll talk about a little bit of that today, but that report goes into it further. So if you articulate the value of a mesh or the functionality of a service mesh, like Istio specifically, you can characterize it. You can bucketize these things in these ways. I'm trying to get all my Zoom windows out of the way here. A lot of times you'll hear about people will speak to the value of a mesh and the functionality of a mesh in about 3 pillars: security, observability, and traffic management. I'm going to toss 5 at you today and see if these don't make sense by the end of Lab 8, by the end of the workshop. So traffic control, we're going to spend a fair bit of time there going through labs on getting fairly granular with how we're going to steer traffic around. Service meshes intercept requests, intercept all of the traffic that go in between each of the individual microservices, micro or macro in Istio's case, whether they're literally running in containers on Kubernetes or running in VMs or on bare metal outside of Kubernetes. Istio supports workloads in either environment. You'll find that some of the mileage between this functionality will vary a little bit. So we're going to look at just Kubernetes workloads today. We're going to use 2 different sample applications. We'll run those both in Kubernetes. But part of the reason that people come to a mesh is to modernize their existing workloads. And I don't know what percentage of the world's workloads is not in Kubernetes. Sometimes it feels like they're all there, but it's a very high percentage that isn't in Kubernetes yet. Lots of things going on outside the cluster. So that's clearly a benefit that Istio brings specifically. So granular traffic control, content-based traffic steering, layer 7 steering. So the ability for a service mesh to intercept those packets, those requests to your services, to do so transparently, to provide you granular control over whether or not to accept them, reject them, redirect them, rewrite them, mutate them maybe, to change them from one protocol to the next. Fairly powerful. As a matter of fact, even though we're on record here, I'll say that that particular notion is part of why I left Cisco in my role so many years ago. Frustrated that we weren't doing more there with the network. So super pleased about sort of this next gen SDN, if you will, a service mesh. Resiliency is something that a service mesh very much so provides. It's fairly universal functionality that a mesh will give you, things like retries, the ability to drop packets, so inject faults, to rate limit, to do so. Some of them let you do so very intelligently. Security, so each service mesh brings its own identity and sense of identity. They will automatically assign a unique identity, a certificate to each individual workload, to each individual service. It's through that a few different things are facilitated, most notably mutual TLS, like our mutual authentication and encryption in between your services. For some people, for some organizations, that's like, that's the golden ticket. That's like the entire reason that they're deploying the mesh, is to be able to get that east-west traffic in between their services secured. And for others, they never turn it on. For others, they're here for the observability, the metrics, the logs, the traces, the uniformity of observability that's offered. That's what, as a matter of fact, the majority of individuals that I speak with, it's observability that gets them hooked. There's a fifth area, a bucket of functionality that I would say I think is most intriguing and is somewhat emergent for service meshes. And we'll get to an example of this today. But it's about manipulating business logic in the network. The network sees all this traffic, can do some intelligent things. I think that people can expect more from their service mesh as time goes on. I'll stop there and we'll just give an example of that later. It'll be about infrastructure logic that's inside of your apps, pulling out more of that than I think that some of you are aware of today. So Istio specifically, in its definition, and it's an open platform, I was saying earlier, to connect, manage, and secure microservices. So each of these features, Istio delivers in spades. Istio itself, as a project, what was it? I have to go back and look. Was it like 2007, March 2017 was first announced, I think. So it's gone through its own iterations. We're going to deal with Istio 1.9 today in the labs. So the latest and greatest. I think 1.9, was it just last week it come out? In version 1.5, between 1.5 and 1.6, some significant architectural changes occurred in the project. We'll look at that. So I had said before, observability, it's a big deal. It takes the blinders off for a lot of people. Some people are still flying blind with what's going on in their cluster, what's happening in their services. It's not this isn't to necessarily be entirely oversold. When you look at the metrics, the logs, and the traces that we will see today, that there's a difference between, well, and I hesitate to use these terms. I still haven't figured out better ones just yet, but in our industry, it had been referred to as like white box monitoring. So your ability to see inside of the application and what's going on inside the app, and black box monitoring, where the system itself, the application, is opaque, and you're just getting telemetry, or you're able to observe it from the outside. That's the service mesh kind of does both. So the metrics and, well, the default metrics and the default logs that Istio will generate is really focused on traffic that's going to and fro your services, less so about internal logs generated from the application itself, from the business logic that you've written that you're running. It will still facilitate, alongside Kubernetes or what have you, it will still facilitate the collection of those, but the metrics and the logs that you're going to see are much more about from an opaque perspective. The distributed tracing that a service mesh facilitates, now that's much more what's happening inside of your app. And you can answer some really difficult questions with distributed traces. You're able to, one of those tough questions is like, it is like, hey, why is my service slow? It's not, why is my service down? Like, you can tell the service is down, it's not responding. And you can go figure out why that is. But if it's slow, that's often a lot harder to answer. So Another big category we mentioned was, fine-grained traffic control. The resiliency, I mentioned a couple of things around retries and fault injection, but there's timeouts. There's some service meshes, not Istio, like have error budgets, circuit breakers and health checks, very powerful things. There's some chaos engineering that can be done on top of Istio. So the ingress and egress routing, we're going to look at. Egress ends up being used a lot of times with a security-oriented focus about what's exiting your apps, what's exiting your infrastructure, who's reaching out, and what that data is. So I'm stoked about what service meshes bring. One thing that I don't know that a lot of people like reflect on that much or speak to is, we talked about in somewhat hard terms what a mesh will provide, what Istio will provide. But also in these softer terms, Istio and other meshes will provide value to these individual personas. These are, not everyone falls into these particular 3 buckets, but I think it's, from my perspective, it's probably most obvious how a service mesh benefits an operator by way of the observability, the things that we just prattled off, right? The ability for them to get that type of a control in one place, described declaratively, over their infrastructure, over the services. Well, the same thing, developers can be empowered through that white box, the distributed tracing that we just mentioned, the uniformity of information that they get out of a mesh. Product owners as well can be empowered to the extent that, you can, I was mentioning before, you can manipulate packets. We're going to go through an example about some work that we're doing with Docker on Docker Hub. We'll go through a lab where we'll use a sample app to show you how a product owner is enabled by a service mesh, doesn't necessarily have to go to the development teams to ask them to change the behavior of their app. They can just change the behavior by updating some YAML or by reconfiguring the service mesh. Okay. Let's, so I want to get, so we're going through concepts. This is good, but I do want to get your fingers on the keyboards sooner than later before we all get bored. I'll highlight these things real briefly and we'll move on. That is to say, service meshes are a thing in part because container orchestrators don't bring all that you need. They do some things by layer 7, clearly. There's so many sort of, this is a little bit tongue in cheek, but there's so many layer 4 and below concerns about the infrastructure, nodes and clusters and admission and et cetera, scheduling and resources that some of those higher layer needs have been left unmet, and hence service meshes have stepped forward to fill some of that gap. You're all familiar with API gateways, microservices, API gateways. There's like quite clearly overlap with a service mesh and its functionality, in part because literally the same proxies that Istio and other meshes will use are literally the same API gateway, the same technologies that you use in your API gateway. A lot of the difference comes down to the deployment models and what the placement of those proxies. If you think about, if you wanted to make a highly resilient application and have it deployed in a highly resilient and highly scalable way, well, you'd have many points of indirection. You'd have if you had a 3-tiered web application database tier, you would have a virtual IP address or a load balancer in between each of those 3 tiers, one out in front and then in between each of those 3 tiers. Well, and that's great. You've got a nice resilient 3 tiers, 3-tier architecture. If you were to take those proxies and proliferate them, one for each individual service, for each individual part of your app, so much more control, so much more resilient. There's a little bit of overhead to manage and balance there. And that's been a study of ours. We'll take a look at that in one of the labs. Cool. A lot of times people will describe a mesh about getting infrastructure concerns out of your services. Yep. I'm skipping through some of this trying to get to the lab. So I think some of this is hopefully fairly obvious to you as you think about whether or not to write this logic about when to retry a failed connection request, or when to rate limit a client from hammering on your service. You can write that in code, or you can just ask the mesh to do it. So I guess in summary, service meshes or Istio is used to modernize existing infrastructure. Istio specifically works with VMs and bare metal, applications running on VMs and bare metal services. Helps provide people a bridge. You can deploy your Ingress Istio gateway and start to, that gateway can be a gateway to a full-blown service mesh. One interesting thing that I alluded to, but I don't know is entirely obvious, that on that slide where we looked at developers, product owners, and operators, is that today, if you reflect, and actually for anyone who'd like to share in the chat, for those that are running Istio now, I'm particularly curious if this has been your experience, or what your how you currently operate is. There can be something of a diffusion of responsibility between, if we boil the world down to just developers and operators, like who's responsible for defining and enforcing a rate limit? Is that the developer, or is that the operator? For a retry, where should that be implemented, and who should decide how many times you should retry? And by the way, that probably changes over time as your infrastructure changes as well. My hunch is, and again, please sound off if you would, my hunch is that the answers here are different in different environments. Service meshes hopefully bring some uniformity to that. And irrespective of who it is, whose responsibility it is, it becomes evident that there's a single place to define the behavior of, I was using retries as an example, but to define this behavior. And that responsibility is no longer diffused. So, okay. We're on the cusp of getting our fingers warm. It's important for us to just level set briefly on a high level architecture. We talk about service mesh planes, the planes of the service mesh of Istio, and all meshes. Data plane, control plane, management plane. Anybody here, network engineer by trade, network administrator in the past? There's a lot of the power of the mesh is about networking and enabling hopefully all of the rest of us non-networking folks with the power of a network and putting it into our hands. The workhorse of the service mesh are the proxies that reside in the data plane. They're intercepting, this is the in-band aspect of a mesh. They're intercepting and seeing each of the requests that go to your services, and hence the power of a mesh, like the ability for them to do any number of things with those packets, generate telemetry, block things, require, authorize things. Some meshes, Istio comes with an ingress and an egress gateway, but not all meshes bring those, or that they can be optional for some. The egress gateway can be an optional thing for Istio deployments. The control plane is where the service mesh is something of an element management system. If you think of your collection of proxies as elements to be managed, proxies to be managed, the control plane, one way of describing it, there's a lot that goes on there, but one way of describing it is as a configuration management for your proxies, a configuration management for Envoy in this case. It's where a lot of you will interface with Istio and configure the mesh. To the extent that there's a number of things that you might want to facilitate on top of a mesh and harness the power of a mesh, you might want to do chaos engineering. You might want to have some expanded governance, expanded policy. You might want to have approval flows about who can change what. And you might want to do multi-mesh things between different types of service meshes. You might want to get some additional observability. Like there's a long list of things that you might want to do with a management plane. So I'd asked if any of you are network, or of a networking background, because these terms are sort of embroiled in the annals of network engineering. Like they're fairly familiar. And for a lot of you who have been doing things in and around Kubernetes, control planes and kind of data planes are probably, if you think of the Kubernetes Kube API, kind of the Kubernetes, what do we call it now? Not masters but anyway, the Kubernetes control plane that controls your nodes and is responsible for the cluster itself, the nodes being the workhorses again. There's kind of a direct analogy here. Great. Okay, on Istio specifically, this slide, this architecture that you're seeing here is updated. And I'm intentionally showing this because it shows that there's different functions that are happening within the control plane. So today, when we go through the labs, we won't see each of these components that are called out by older names, Citadel, Mixer, Pilot, Galley. We won't see them in our labs explicitly. We'll see them implicitly inside of a single binary. That binary or that app is called Istio daemon. But the functionalities that Pilot and Galley and Citadel and Mixer have done in the past are, for the most part, still around. It's just that they're not out of the box. They're not necessarily deployed individually. A lot of different deployment models for Istio, though. So to be clear, like this is the way that, one way of visualizing how it is that requests enter into Istio through the Ingress gateway. First kind of point of entry. The traffic is, it's through the proxies that traffic is directed. Traffic is never directly directed to or directly reach the application itself, the application container. That's essentially the difference between the containers that you might be running in a container orchestrator today, those applications, those that are not on the mesh. That's essentially the difference for them being on the mesh, is that they've got a proxy in front of them. Now for Istio, that proxy is sidecard. So it's in the same pod in Kubernetes. For a couple of other service meshes, that's not the case. They use node level proxies. There's some trade-offs there to those different designs. There's a couple of other, some architectures here about other service meshes, how they work, what they're written in, some interesting things. We end up, at layer 5, end up dealing a lot with other service meshes. And so some interesting things, but we're here at IstioCon. So the control plane, and actually Pilot and Galley, like those prior names for these components, like there's an aspect of Istio that's responsible for synchronizing service discovery. Like Istio itself needs to be very tightly aware of the state of Kubernetes or whatever underlying platform that you're running, and understand as and when Istio or Kubernetes reschedules or schedules existing or new services, so that it can be aware of the state of the cluster, and in turn take that configuration and that understanding and inform and push that configuration to the data plane, to each of the envoys that are running. So that's an ongoing process that needs to be there. Mixer is probably the biggest shift. I had mentioned kind of in 1.5 to 1.6. It was basically going to something of what's referred to as a mixerless model. So taking Mixer out of the control plane and moving it, which is Mixer is about telemetry gathering, or it was in the past. Now these telemetry filters are WebAssembly based envoy filters that are responsible for some of the same things. So responsible for generating telemetry, logs, and some metrics, but reside in the data plane. And there's been performance improvements there's been a little bit of functionality that's been left behind, but there's also been some performance improvements through this model of moving from Mixer to telemetry filters. So kind of like this. Cool. So okay. Again, we won't look at a component called Citadel today, but this capability is inside of Istio, and that is a managed certificate authority. So this certificate authority provides verifiable identity. It generates certificates and manages them, refreshes them, rotates them, assigns a certificate per service. Each individual workload that gets onboarded onto the mesh gets a unique identity, and that is used for authentication, authorization, traffic encryption. Okay, good. There's a landscape out there. If you're interested in the other service meshes, a landscape you might want to go check out. A lot of details about when they came to be, how they work. It's at layer 5io/landscape, but lesser important at IstioCon. I'm bringing this up that there's a number of meshes out there. If we get to the end of our workshop and we want to talk about multi-mesh things or some of the specifications, the standards that describe them, we will. We'll look at service mesh performance as a standard here just through our labs, and how SMI, service mesh interface, if these terms are new to you, and if they're of interest, come and ask after the workshop. Okay, so lastly, I think this is the last concept, is I mentioned service mesh patterns as, well, the first of a two-part book series on service mesh patterns, 30 patterns per book. The early release, I think, is going to come out in about a week. We have shared the list of those 60 different patterns, at least the names of them and the categories of them. So the link used to be in this slide. I don't see it now, but if that's of interest to you, ping. Okay, let me skip over this. Okay, good. So questions. We're going to go through the last prereq. So we talked about Docker, Kubernetes, and our last prereq to get into our first lab is to install Meshery. So it's a management plane, service mesh management plane. It's within the CNCF landscape. It's discussed a lot inside the CNCF service mesh working group. It implements both service mesh performance and service mesh interface to help manage Istio. It'll be very useful for us today. One, because Meshery was built for this here, for workshops. It was born of workshops, to help people learn service meshes, operate them well. Also to answer questions about what I had said before, that the data plane is the workhorse of a service mesh, and that you need to pay for that functionality. And by pay for, I mean there's a little bit of there's some performance to manage. How much CPU, how much memory, how much latency are you incurring based on what you're turning on in the mesh? For my part, I would consistently and perpetually say that it's absolutely worth the overhead. If you're getting metrics or logs or traffic control somewhere else today, you're paying for it over there. As you deploy Istio and you get that in a central place and you get uniform governance over that and a uniform way of having all that operate, you're paying for it in the same way here. It's actually just easier to measure what that overhead is. So that's another reason why we'll use Meshery today, is it's going to help us get up Istio very fast, get up a bunch of different sample apps, and it'll generate, it has a few different load generators built in with some statistical analysis, some performance analysis that it does. That'll be helpful to us as we do some traffic splitting and explore some of the resiliency aspects of traffic management. So the way to get Meshery going, it depends upon what type of system you're running. The way that I'll end up running it today is, I mentioned earlier in the call, I'll use Docker Desktop I'm on a Mac. I'll use Docker Desktop on the Mac. You don't have to be using that as your Kubernetes platform. Since if you're on Mac or Linux, probably the easiest way to install Meshery is If you use Brew as a package manager, great. If you're on Windows, that's fine as well. There's a package for Scoop. If you use Scoop, if not, there's instructions for a bunch of different platforms at meshery.io. So now's a good time to take a moment to get Meshery going. This bash script will work for Mac or Linux. It may even work for Windows. I don't remember. So I'm going to get my fingers a little warmed up and we're going to get this prereq installed. And maybe we'll pause for a break after this and get into the labs. So I mentioned before, if you're using Brew, I'll make this bigger. That's a convenient way of getting Meshery CTL. Meshery CTL is the command line client for Meshery. There is a new, well, it'll be announced this week. There's a new version of Meshery. The latest version is v0.5. Meshery as a project is about a year and a half, coming up close to 2 years old now. Like I said before, it was built out of workshops like this, questions that we keep getting from different people. So there's a release candidate, an RC2, that should be available to everyone. So once you have the command line client, you can, I'm just going to verify what version I'm running, Meshery CTL version v0.50 RC2. Great.
Lee, just quick question. Should we be watching your terminal or? Oh, okay, that's fine. Just wanted to make sure. Just wanted to make sure.
Yeah, sorry. Yes, you should be watching the terminal, but.
Okay, yeah, that's now the terminal. Yeah, because we were still watching the slides. So.
Yeah.
Okay, yeah, that's fine.
Well, is that we're going to have to keep count. Is that the second time or is that the third time?
No worries. No worries. We're here for you.
Thanks. I apologize. So what I, just as a brief recap, nothing special. What I had done is I just run brew upgrade Meshery CTL. For others, if you're installing fresh, it's more of a brew install. Brew install, and you'll get the tab for the, if you're using Homebrew here, you run Meshery CTL system start. I'm going to copy that. If you'd rather use a bash, this is here. There's a list of different install methods. Now, depending upon what Kubernetes environment you're running, you might need to do a little bit of setup to have Meshery connect to your Kubernetes environment. So again, I'm running Docker desktop. In Docker desktop, I've enabled, if you go to your preferences, I've enabled Kubernetes. It's a really convenient way of getting a Kubernetes environment. You don't have to be running this. You'll do a Meshery CTL system start. If you're not running Docker, it'll probably say Docker's not running. Do you want to start it? If it's your very first time running Meshery, it'll probably also say, hey, you don't have a context configured, and you do want to configure a context. Context is, it's not very different from a kubectl context. It describes a Meshery deployment. When Meshery installs, that command line client keeps track of its context. It keeps track of how many Meshery deployments you're managing in a config file in your user's home directory under a hidden folder .meshery. That config file is here. It's just a simple YAML file that describes your Meshery deployment. So mine, I'm going to use Docker as my platform. And hopefully each of you will as well. Even if you have a Kubernetes system, still it's probably most convenient to spin up Meshery on Docker and point it at your cluster. So Meshery, in this case, is running external to your cluster. It's fine too if you want to go ahead and deploy Meshery as an app inside of Kubernetes. That's fine as well. The labs assume that you're doing it outside, though, that you're doing it in Docker. Good. So you do a Meshery CTL system start. That should do a couple of things. It'll download different adapters for managing different service meshes. Clearly, we're focused on Istio. It should also pull up your system's default browser. When you get there, you'll see this screen. You'll see the screen to sign in and choose a Meshery provider. We work with a couple different universities on research around the performance of a service mesh, and depending upon what provider you choose, you can either, I think right now that there's two that you'll see. One is to not use a provider at all, which means that you'll use Meshery as just a single tool, as an ephemeral tool that you sort of pull out of your tool bag, use for the moment. It won't remember any settings or configuration that you do. Alternatively, you can use this Meshery remote provider, and you'll create an account so that it can remember your configuration settings, can remember if you run performance tests that will run today, it will remember those so that you can retrieve them and pull them up later as well. So either way you go is fine. It will work with today's labs. So, okay, good. So with that prereq done, we're ready for our first lab. And by the way, we're also ready probably for a link to our labs. I think Pedro had said that he'd shared a link to the labs with all of you. I'm going to share two links with you. And actually, Abishek, if you don't mind to share, I mentioned earlier on the call, there's two workshops that we'll deliver. One is, and we'll start with this one. It's the intro to Istio. And then there's the advanced Istio, and we're going to try to combine them a little bit today to hopefully get all of you on both ends of the spectrum of where you're at. So at bat will be to go out to this Istio workshop here. So there's a lot of labs between these two, between the Istio Service Mesh workshop here and the advanced Istio Service Mesh workshop. We will very intentionally not get to all those labs, but they're there for self-study. Please study them. Some of you are finding broken links to old images, maybe old pictures. Please fix them, or please mention them. Please point them out so that others can get them fixed. Okay, so to start with, we'll go to the Istio Service Mesh workshop, this introduction to Istio. If you are stumbling on the prereqs, raise your hand and ask for help, or walk through each of the steps that you see listed in here. For the most part, it sounded like a lot of you are comfortable with Docker, at least somewhat comfortable with Kubernetes. You don't need to be a Kubernetes expert to go through this. So in lab one, we're going to set up Istio and get it deployed. Now, let me orient you to the labs a little bit. So today we're going to walk through these workshops using Meshery, also hitting Istio directly and exploring Istio internals. The labs, when you walk through, they're sort of each of the labs are broken into two sections. So the top of the lab is about how to use Meshery to go through the lab, to deploy Istio, deploy applications, do the things. If either your preferences or if you get stuck in Meshery, if there's a second section in each lab, that's an appendix. It's more of how you would do it manually or how you would do it just from CLI. And so you can compare and contrast the two, or walk through all the labs using one and then come back and walk through all the labs doing the other. Whatever is more useful to you. Okay, so lab one is install Istio. So we'll go over to, we'll go into Meshery. I'm going to blow this up a little bit. It's a somewhat common question people will ask, hey, do I need to have all these adapters for the other service meshes? No, you don't. And you can turn those off so that Meshery just has the one adapter, Istio. The value of Meshery really isn't so much about managing all the other meshes. It's more about, well, some things that we'll walk through. It's about, I won't spoil the surprise, but we'll see. So when you're signed in, you'll need to, one of the first things you need to do is make sure, verify that you're able to talk to Kubernetes. What Meshery does, it really tries to make the install process very easy. So you install Meshery, it automatically brings up your browser. It searches for it searches in your home directory for your user's kube config. So it will leverage your user's kube config, assuming that that's probably what you'd want, the Kubernetes environment that you want to use. If that's not the case, or if you need to change that, you can go to the settings area. Let me bring up a new browser. And load up your kube config. So for me, it's Docker desktop. You can click on this chip here just to make sure that Meshery is in communication with Kubernetes. So we're working with a release candidate that I think has a bug in it on its settings area. So if you run into this and if that's an issue for you, let folks know in chat. No, so great question about like the version of Istio that we're going to be working with today and whether or not that really matters. It doesn't. The labs that we're going to use should be just fine going back from 1.9 is what Meshery is going to want to deploy. Going back to like 1.5 should be fine. And so, good, okay. So by the way, if you already have a service mesh deployed in, or Istio, sorry, it deployed in your Kubernetes environment, Meshery should detect that and show it to you. But assuming that you don't, let's do a couple of things. I'm gonna navigate over to the Istio section. I'm gonna minimize this a little bit just to get some space back on the UI. I want to go ahead and see if we can set up a watch on Kubernetes. We should probably familiarize a little bit with the Kubernetes environment that we're using. So in the workshops today, you'll see me just use K as an alias for kubectl. The Kubernetes version that I'm running is 1.19.3. That's what comes in Docker Desktop. The client that I'm running is a little bit newer. That's fine. I'll move this down. I'm going to go ahead and then I'm just using these aliases, kubectl get pods. And so this is a fresh install of Kubernetes. So get pods, all namespaces. I'm just going to set up a watch here so that we can see as changes go on as we walk through this. So for all of the namespaces, it's really just kube system that's got anything deployed in it. Wow, real estate management of this screen. Okay, so to install Istio, you'll go over to managing the lifecycle of your service mesh. So you will, by the way, if you want to verify connectivity to your Istio, the adapter that Meshery uses to talk to Istio, you can click on it and test it out. If you're having problems, message in the chat. I don't see that anybody's having problems though. Good. First step, install Istio. This installation is meant to be easy. It's meant to, it defaults the demo profile of Istio. So Istio has this concept of configuration profiles, and of which Istio has a few published. One of them is called demo, which includes, which enables a few features that we will use so that we can learn a lot about Istio. So immediately when we do that, we'll see that a new namespace is created called Istio system. Istio D, which has a lot of the functionality that we were talking about before, the galley and the pilot, the citadel, that type of functionality baked in. And also that demo profile deploys with an ingress gateway and an egress gateway. Inside of these ingress and egress gateways is an Envoy instance. Okay, let's go back to the lab. So lab 1. Is installing Istio. Get Istio system there. Lab 2, let's deploy a sample app. It's Istio's default sample app, or its canonical sample app, is called Bookinfo. Many of you are familiar with it already, and many of you aren't. This is a great way of describing how it is that those sidecard proxies come into play and get used within a service mesh, get used within Istio. So one thing that we could do, I guess, just before looking at Bookinfo is to take a little bit more of a look at, we looked at the pods inside of Istio system. You can take a look at some of the services that are there as well in your Istio system namespace. And so you've got one service for each of those pods. The ingress gateway is probably the one that is most intriguing, at least initially. It's our point of, well, it's our point of entry where traffic that wants to reach services that you've onboarded into Istio, it's the point of, I keep wanting to say ingress, but the point of entry for where those requests come in. It's the first point of control. It's the first point to potentially generate some telemetry, first point to reject some packets or redirect them. And so as such, by default, it comes with a few open ports. So as we go to go into lab 2 and deploy Bookinfo as a sample, as an application, let's look at let's take a look at that app a little bit more in depth. And let's also, I think, begin to understand some of the fundamentals of how it is that some of the magic sprinkles in Istio work around automatic sidecar injection. Before we talk about that, I'm gonna explain this Bookinfo sample app. We're gonna use this app throughout the labs. The app is a beautiful sample application, not because it has a behemoth Java app, which is frustrating sometimes, but because it is an application that's made up of 4 different services, each service written in a different language, showing off part of the power of a service mesh that you get all of this functionality irrespective of what language your apps are written in. So this application in terms of functionality is very simple. It's a web-based book catalog or catalog of books that people can use to review books, look at them, their details, and assign stars to them. So fairly small in nature. When you can take this sample application and deploy it off the mesh, off of Istio, and go poke at it and run it. And when you pull up its web pages and look at the reviews of the different books, the traffic flow will look like this. Those yellow lines represent requests that are made from, well, starting out here from you, those requests that go in and are directed to the application itself, directly to the application. The application responds to the requests. When we go to deploy this sample application and we do so on Istio, Istio will, by default, it will automatically well, I shouldn't say by default. Anyway, Istio will automatically inject an Envoy as a sidecar adjacent to each of the application containers. And by adjacent, we mean inside the same pod. Kubernetes pods share the same networking namespace. So the same local host, that same interface, that same loopback 0 is shared between Envoy as an intelligent and capable proxy and your application containers. If they can both, they can both speak to local hosts, and they'll basically be talking to themselves because they're both local hosts is the same thing to each of them. And therein lie, in part, some of the magic sprinkles, if you will, of how Envoy gets sidecarred as a proxy transparently adjacent to your application. And part of how we'll look at actually, so we're going to go deploy this sample app and we'll look a bit more in specific about how traffic is being redirected, how this works, how it is that traffic no longer is directly goes from application to application, but instead traffic goes from proxy to proxy. Okay, go back up here. So these sidecars, by default, they get automatically injected, like I'd said. This injection in the way that Istio controls this is through labels on, well, it's in a couple of different ways, but most generally is based on labels associated to your namespace. So you would take and label a namespace, and a namespace that carries the this injection label is what Istio will work with a Kubernetes admission controller, and it will register a mutating webhook to ensure that anytime a new service is to be a new workload, a new service is to be scheduled into a namespace that has this label, that a sidecar is that Envoy is inserted in to that manifest, that application manifest. Automatically, Envoy is inserted in and becomes a second container. So today, and this is something you could do with Meshery real quickly, is you can go deploy Bookinfo off the mesh and see it deployed. You'll see just one pod. Oh, I'm sorry, one container per pod. If you do that. So to do that, since I'm talking about it, we'll do it real quick. kubectl, get pods. Let's sit here and watch for any pods to come up. If we go into Meshery, we can take, well, what's nice here is that you can take Bookinfo or other service meshes, sample applications, and cross-pollinate them, so to speak, across different meshes to better learn and understand how they work. So we're working with Bookinfo currently. We're deploying that into the default namespace of your Kubernetes cluster. As it comes up, you'll see that there's one container running and ready of one container. When to explore this a little bit, that means that this app is running off the mesh. It hasn't been onboarded. To explore that a little bit, you'll be able to, in the labs, you'll find instructions for exploring that label that I was referring to. So here, so the label is the sidecar injector. You can look at the presence of that pod, the sidecar injector, as a pod itself. This may be old. And and also verify whether or not your namespace has the label Istio injection on it. right now, we're running in an environment in which it was a fresh Kubernetes system. So the default namespace does not carry Istio injection as a label. So when you deploy an application like we just did into that default namespace, you won't have the sidecar automatically injected. If you go annotate or go label that namespace, that's going to change how we're going to, that will make sure that all the apps get sidecarred, their proxy sidecarred. Before we do this, we'll probably go back and I'll just remove that Bookinfo application from the mesh or from Kubernetes. And see that that's terminating. We'll go ahead and use Meshery to apply different configuration like automatic sidecar injection. And so this will label the default namespace. So you should be seeing messages like this. So Istio injection label has been enabled on the default namespace. And that's because the default namespace was specified here. So if we go back to run our get namespace with Istio injection label, now see that that label is set on the default namespace and it's set to enabled. So again, if we go back and watch our pods, and now that we've got our default namespace labeled with Istio injection, when you redeploy the sample app, you'll see that it has 2 of 2 containers running in each pod. To explore that a little bit more, it's actually not just the fact that there's 2 containers in each pod. There's actually a 3rd container that had been there ever so briefly. So let's look at that. What do I mean by that? So we can get our list of pods. Take any one of the Bookinfo's pods. It doesn't matter which. And we can get that pod and output its innards, in terms of its running config in YAML. So you can do a -o YAML, or you could describe it. Either way, if you take a look at, if we can go back to the top of this. So a lot of this should be familiar to you, but if you take a look and search for the our containers stanza or containers section, we'll see that we've got a container, our application container. The name of that container is product page. If you keep going, you'll find that you've got other containers in your pod. I'm sorry, I'm looking at the wrong area. Sorry, if you go to spec containers, you'll find that you've got the 2 containers that you're thinking should be there. So your product page container and your Istio proxy, your Envoy. So here's your Istio proxy and it running as Envoy. What you may not have been entirely aware of before is this notion of an init container, an initialization container, one that runs ever so briefly to do some pre-provisioning before Envoy comes up. That pre-provisioning work that's done is to run a small script to reconfigure IP tables within that pod. It's those IP tables then that get configured to redirect traffic, all inbound traffic to the pod, to first go through the sidecar proxy, to first go through Envoy, and then to be passed along, assuming that assuming that that traffic is good to be passed along to your application. And on the reverse is true when your application goes to address either an upstream service or to pass along that request. For that, those IP table rules will be in effect to ensure that that traffic is routed again back through Envoy, through that sidecar proxy, to have any policy applied, if any, and then directed to where it needs to go. And so, yeah, there's an init container that runs very quickly that performs that task of reconfiguring IP tables. You can, there's ways to manually control when a sidecar, when a proxy is sidecar and when it's not. Historically, it's been based on labels on the namespace. Okay. Okay, so we're up to lab 3. Now is probably actually maybe a good time to take just a brief break or to look at some of the questions that we have. Do we have any unanswered questions? Is everybody kind of up to where we are in lab, at least up to lab 3? At least from what I'm seeing, that seems to be the case. Good. Okay, so maybe we'll do lab 3 and then maybe take a short bio break for everyone. Assuming you all have regular sized bladders. Okay. So thus far, okay, yeah. So thus far we've got Istio up. We've explored how it will sidecar, what the proxies do, how they can get sidecarred automatically, how traffic get redirected, the fact that you can take sample apps like Bookinfo, deploy them on the mesh, off the mesh, on the mesh being when, you know, more or less being defined by when it has a proxy that's sidecarred to it. And we mentioned that there were 2 other components that got deployed when Istio got deployed, and that was the ingress gateway, the egress gateway. If we can go take a look at the ingress gateway, this is the point of entry for traffic coming in and traffic that will be directed to the first application in the Bookinfo app. That application is called product page. So let's go into lab 3. So to inspect the ingress gateway. The ingress gateway, just like the proxies that are sidecarred to your app, they contain an instance of Envoy. And let's go take a look at that instance and just look at the Envoy config real quick. If you feel like you haven't seen enough YAML, then let's make sure that you get your fill of YAML. Let's go take a look at an Envoy config. Okay. So to slow this down a little bit, if you go and look at the Istio system namespace, you'll have had the ingress gateway that we looked at previously deployed. If we take a look at that and output to YAML, we'll see these same ports that have been opened to be able to receive and traffic inbound. Right now, that ingress gateway is running as a type load balancer. Wow, there's not much to look at here. Okay. The other part of the lab, I think, was talking about getting into that ingress gateway. So if we get our pods, we can get inside of this ingress gateway. If you get your pods, grab the name of the ingress gateway and do what kubectl exec it the name of your pod. And in this case, they're you'll just put the name of the pod itself. And if, hold on. You'll also need to specify the namespace. Okay. So once you're inside, this is an instance of Envoy. Go look around. If you're since you're inside Envoy, you can take a look at some of the Envoy exposes a lot of metrics. It exposes. It's popular in part because it has well-written APIs that service mesh control planes can be wrapped around. You can, once you're inside of it, you can curl those APIs, curl those interfaces, and look at some of its statistics, whether or not it has a WebAssembly filter running or not, in this case. You can also take a look at its configuration. So I was talking about YAML. You'll find that config under etc PC. Actually, I think this is that particular location is covered in a different. We'll save that for another lab. Good. Now okay, so obviously Ingress gateways are fundamental to the way in which Istio does traffic management. There's a few core concepts to Istio's traffic management. Gateways, sidecars, we've been talking about these. A couple of logical constructs. So there's there's a physical gateway that we're looking at here. There's a logical gateway that you can configure, a configuration that you can apply to your physical gateway. There are destination rules and virtual services as well. We'll look at those. So let's exit out of your Ingress gateway and take a look at how it is that some of these logical constructs. Oof. If you do kubectl get, if you take a look at the custom resources that are installed on your system or those that are specifically installed for Istio, you'll see a few of these things that we're talking about. You'll see a custom resource for sidecars, for gateways. We'll be talking about destination rules, virtual services. We also see for the gateways here, if you get that custom resource, and sorry, you can abbreviate gateways as GW if you like. There's a gateway that gets installed when you install Bookinfo using Meshery. And that logical gateway is called the sample app gateway. Behind this logical configuration, we'll deploy a few different sample apps. You can take a look at the config. It's not very long. As a matter of fact, it's about yay long. What this logical configuration, this logical gateway configuration, this custom resource is doing, it gets applied to the physical Ingress gateway. And what it says is that this sample app gateway is interested in traffic that comes in over port 80 and traffic that is of type HTTP, like that is using the protocol HTTP, and traffic that is coming from anywhere. From any host, if they're sending in, if requests are coming in on port 80 and it's HTTP, then allow that, like, hey, configure this gateway this logical gateway to be able to receive that traffic. Okay. Let's also take a look at the virtual services that may or may not be present. So when we installed Bookinfo, there was a virtual service that was deployed along with the Bookinfo manifests. That virtual service is called Bookinfo. This is an appropriate time to talk about what virtual services are and what destination rules are. So let's take a look at this virtual service and then explain it. So if we get the virtual service Bookinfo, and I'll put that to YAML, a little bit of a longer configuration, not by much. So I'll say that a virtual service in Istio is a fundamental building block of Istio's traffic management. It is what's used to do maybe two different things, depending on how you want to think of it. It's used to, used to route traffic. It's also used to match traffic. So for a couple of you that raised your hands as being kind of formerly, or either currently or formerly network engineers, like sometimes you'll work with systems that have traffic matching as a separate construct, a separate thing that you can write out and describe how it is you want to match traffic, then like, what to do with it and having these separate. This is a little bit munged together inside of a virtual service where first, this virtual service is configured and applied to our sample app gateway. Recall that our sample app gateway is interested in traffic on port 80 and HTTP traffic. And that it applies to traffic that is directed to, this virtual service is applied to traffic that's directed to bookinfo.meshery.io. In lab 3, there's a section here about creating DNS entries so that we can do some intelligent things. So we can, use the power of SNI, or service name indicator, to be able to run multiple services behind port 80. So to share port 80 or to share port 443 and expose multiple services behind that port. Service name indicator, or SNI, is used to grab the host name of packets that are coming in, understand where that host name, where those packets are directed by that host name, and use that to read it to do two things. One is to share the same port for traffic that's aimed at two different applications, and then two, to also be able to direct traffic even though it might be encrypted, such that just that service name indicator is exposed. So unterminated TLS traffic can still share the same port as a traffic to other applications. Okay, so again, back to the virtual service. There's the virtual service. Again, this one is applied to the sample app gateway. It is interested in or will function against traffic that's directed to bookinfo.meshery.io, our sample app. And it will match against these paths. So if your traffic is sent to bookinfo.meshery.io/product page, that traffic is of interest and matches this virtual service. Good, same thing for these other paths. So once that match has been made, there's a route stanza, a route section that determines what this virtual service will do with that traffic. In this case, it's going to route it to a particular destination. That destination is the first application in our sample app. The product page is the first service in our sample app. Product page, when deployed internally, or when it's deployed on Kubernetes, in this, it'll be running on port 9080. That's where it exposes its HTTP services. Even though to the outside world, those that are outside the cluster will be addressing to port 80. This virtual service will help us reroute traffic. Okay, so one thing for us to do is to establish some destination rules. So we talked about virtual services. We talked about how virtual services are about matching traffic and routing traffic. Destination rules are another core traffic management construct in Istio. These destination rules are really, they apply much more outbound. They're about defining, they're about applying policy to where traffic is destined as the traffic exits a pod, exits an envoy, exits a proxy. And so one of the more popular things that destination rules are used for is to create subsets, another Istio construct. Subsets meaning that, like, to use the Bookinfo as an example, in Bookinfo, there's one service called the review service that has 3 different versions of the same service. Well, in order to provide Istio control over which traffic might go to which version of the service, you can use destination rules and the subsets to define those. So in lab 3, what you want to do is we want to take it and define these subsets. We want to create new these destination rules. So again, I'm going to go back to Kubernetes. I'm just going to set up this watch again. I'm going to get destination rules in the default namespace. Go over to Meshery, and what we can do is from the lab, you're able to take and copy these destination rules. And so if you look at the destination rules, by the way, the most, there's 2 versions of the rating service and ends up being 3 versions of the reviews service. We'll copy this, go into Meshery, and you can apply custom configuration. You'll click on the play button, apply that in the default namespace, paste in your YAML, paste in your destination rules, and have those applied to Istio, have those applied to your cluster. So we'll see that 4 new destination rules get configured. We won't go introspect them because it's exactly this, what we just pasted in. That gets us set up to go do some interesting traffic management things. Given the time, I'm going to skip over this section about looking at Envoy's config. I'm going to get into some traffic management, get into some observability. So Istio itself comes with a few add-ons, things that they're classified as an add-on. 3 of them that we'll take a look at: Prometheus, Grafana, and Jaeger. These are observability add-ons. To deploy these add-ons, I'm going to stop the watch on destination rules. I'm going to go over and create a watch on pods. To deploy these, I'll go back into Meshery, and well, we will enable Grafana. And if you do that, good, yeah. We'll enable Grafana. We'll see that happen in Istio system in our control plane. So good. That's where we want them. We get Prometheus turned on, maybe Jaeger as well, and have those come up. So we get Jaeger and some Prometheus going on. Meshery, given that it needs to manage any changes going on in the mesh, should then be automatically, it should be aware of where those, of the fact that Prometheus has been deployed. And so I think we've got there's a small bug that was just in this second release candidate that I'm running. And if you're running the same release candidate, you'll end up finding that you'll probably get that page not found. Let me give you all this direct URL where you can, now that you've deployed Prometheus and Grafana, where you can connect Meshery to Prometheus and Grafana. Cool. So here, because Grafana was just deployed, Meshery discovers that you can connect to the address that's inside of your cluster. Connect to it. You can also connect to Prometheus if you like. And then that way, Meshery is immediately able to take advantage of some built-in boards and panels that come with Istio. So those Istio add-ons for Grafana, they ship with, and for Prometheus as well, for all of them, they ship with a default configuration. For Grafana, it ships with a few different boards defined, each of the ones that you see here. We will connect to this, the mesh dashboard and add that. It will just read in the Grafana boards. And display the metrics that you would otherwise see in Grafana. You can also bring up Grafana directly and take a look at those same boards and panels. So in my case, it would be localhost port 3000, given that I'm running on Docker desktop. And you'll see these same dashboards here. It's the mesh dashboard. So really, you're not much going on because we really haven't brought up our sample app and played around with it much. Now, because of what I was talking about before about the virtual services and the destination rules and us having configured those, is that our sample app is ready to go, is ready to be interacted with. And we can see the fact that traffic will go from your client, from your web browser through the Ingress gateway, touch the virtual service and the destination rules, and ultimately land at your app. So as you were following along in the labs, if you've created a default, an entry in your etc hosts, you want to create these local entries, one for bookinfo.meshery.io to point to your local host, and another one for imagehub.meshery.io. These will allow us to, like I said before, to do, to direct traffic external to the cluster. So right now, Meshery is running external to the cluster. You're going to use Meshery to generate a bunch of load against these apps. And so you're able to bring up Bookinfo. The default behavior of Envoy is to round robin traffic requests. So if we sit here refreshing the screen, we'll see requests going in between the 3 versions of our reviews subsets. So again, to refresh the subsets, that we were defining, there were 3 different versions of the reviews service. So if you go over and get the destination rules for reviews and output them to YAML, you'll see that just very simply, there's 3 versions of reviews defined. And these subsets are what Istio will use as the construct to, well, by default, round robin traffic across these versions. So that's the default setting. Let's get into some labs where we begin to manipulate that traffic and tell it to do some different things with routing traffic to different directions. Okay. As a matter of fact, I'm looking at the clock, and a lot of times we'll give this workshop in a much longer setting. So I want to hurry into some of these labs here. So initially, we took and applied, if you go to lab 5, we took and applied these destination rules. So we have these defined. That's what we're just looking at. So if we go down, there's some things that we can begin to do very quickly, which is very simply, you can say, hey, you want to change that behavior from round robining to just going to just restricting it to one version of this reviews service. And to do that, in lab 3, there's a destination rule in lab 3, lab 5.2. This virtual service here called reviews. If we go look at our environment again, we've got, if you get your virtual services, we've got the Bookinfo one that we looked at before. and it matches interesting traffic on those paths like /product page and etc. And then routes that traffic to product page. That's what just happened. That's what's happening currently. If we go take and change and add another virtual service, that's going to affect the how it is that traffic is routed. So this particular virtual service, if we go back to Istio, if we go over and apply a custom configuration here, we'll apply it in our default namespace because that's where our because that's where our sample app is running. So this simply says this will add a new virtual service. It says that it's interested in traffic that's directed to reviews to that application. Traffic that is of type HTTP, go ahead and route that traffic over to only the V1 subset. So this is going to override. So if we go over and refresh our screen on the sample app, as we sit here and refresh, we see that we're seeing only the version 1 of reviews, which has no stars. Okay, neat. Let's look at that. So how many virtual services do we have applied now? Well, 2. So we have our first one, Bookinfo, and now this new one, reviews. Okay. So again, recap. If you take a look at Bookinfo, I'll put that in terms of YAML. Again, it's tethered to the sample app gateway. That gateway was looking for things on port 80. That's HTTP. It's interested in traffic that's being directed to this host name, bookinfo.meshery.io, and matches traffic with these paths, routes it over to product page. Great. We look at the virtual service that we just applied, reviews. Very simple. These are additive. These 2 virtual services are running. They're being compiled, if you will, by Istio. If you think about like firewall rules and how they're interpreted kind of top down, Istio does this as well. It will add these virtual services together, look for its first its matches. If there's happens to be a tie or traffic that gets matched in the same match by 2 different virtual services, Istio will use the virtual service that was first created, so the timestamp of the first one, to kind of break that conflict, to break that tie, and let that supersede the decision on where to route the traffic. In this case, these are complementary virtual services, and so this second virtual service, it applies and is interested in traffic that is directed at the host's service, whereas the first Bookinfo virtual service is interested in traffic that's directed at Bookinfo. So this is like traffic that's going to hit that first application product page. Right? It matches this. It matches here. As product page looks up what those reviews are against the individual books, this virtual service matches traffic that's directed to reviews. And what it says is you'll only get version 1 of reviews, and that's what's happening. Okay, great. So here's the nice thing about the rest of our labs is that if you have these foundational concepts understood, and I know that it took us a while to get to these, but intentionally so that hopefully everyone could follow along, is that now we can kind of pick up the pace and go through any number of combinations of how to get very granular with matching traffic based on any number of things. One of the first things I think we'll take a look at is, well, content-based routing. And I'm gonna be aware of the time here. So we'll hit a couple of these briefly. Let me skip this and go to something a little more interesting. This 5.4. So if you wanted to do traffic splitting or traffic shifting, if you wanted to canary between one version of your service to another, well, you might assign a certain percentage of the traffic to go to that new version, test it out, make sure it's good for some time. You might incrementally continue to shift more of that traffic over to your new version. And so that's what 5.4 is looking at, is splitting the traffic 50-50 between V1 of reviews and V3 of reviews. So let's go ahead and grab this virtual service. Go back to Meshery. Let's apply this configuration. We're just going to apply it. We're going to overwrite the existing reviews virtual service. We'll apply that. You can come verify that's been updated. And so it has. Here's your reviews virtual service. Now it's doing traffic splitting 50-50. So if we go over and look at that, just by refreshing the browser, great. We're seeing we're not seeing any black stars. We're just seeing either no stars or red stars. Great. Well, to make things a little more interesting, especially as you go to try out some of the other labs that are there, you want to end up using. You want to generate some load, some significant load, and really see how well Istio is, how well it does in terms of sticking to 50% between them. Let's generate some load briefly. So for some of you, you might run into some networking issues here. I'm going to move quickly anyway. This really depends on your environment and what you've got set up. The labs walk through this more slowly. I'm using Docker Desktop. So I'm running, as a reminder, I'm running Meshery in Docker, which is its own network. And then and that's external to my Kubernetes cluster. I got Kubernetes running. I've got Bookinfo running inside of it. So Meshery is representative of most of where your users would normally be. Your users are external to your cluster, and in this case, so is Meshery. So as Meshery goes to address work or address or send traffic to Bookinfo, we can use this performance test to generate a bunch of load. So in this case, we're using Istio. Give this a name. You don't have to give it a name. In this case, the URL that I'm going to test is because Docker Desktop is also running Kubernetes. I'll use my host machine's IP address. My Mac has an IP of 192.1.15 on my local network. That's my wireless address. I'll generate a bunch of traffic and send it to /product page because Docker Desktop is sharing that same interface with Kubernetes. Set it to run for some amount of time. When I set it to run, I'm also going to pass in a host header to identify where I would like for this traffic to go. Like what host am I identifying, sending this traffic to? Host header, the format here looks like this. So I want for this traffic generator inside of Meshery to every time it generates this load to add this HTTP header host. Where do we want to send it? We want to send it to bookinfo.meshery.io. Because that's again the mapping that we used on our application gateway, our sample application gateway. You can play with different settings here, and you can use different load generators if you want. I'm just going to run this one for about 15 seconds. If you've connected to Grafana, you will be able to do a few things. You'll be able to look over certain time ranges, and by default, it's set to live tail metrics that are coming through. So when this is done, Meshery will generate a statistical analysis. Statistical analysis. It'll generate a histogram showing you your P50, your P90, P99, P99.9. It'll tell you a bunch of statistics. It will say that, hey, there wasn't any errors. This is the averages. This is what you're looking at. It'll also, if you connected to Grafana and are pulling in any of those dashboards, it will show you what's going on. So we have two virtual services, the two that we had. Got our destination rules, only one gateway. You can connect up your Grafana boards to look to verify that you're in fact that Istio is in fact splitting the traffic 50-50. And actually, we just missed it right here. Go run this again. I'll go run this again real quick to show you there. This actually isn't this is, I think, just kind of a high level, how many operations per second are happening. Well, this is not what I want to be showing, happening across reviews V1 and reviews V3. We should be seeing basically an equal split. Reviews V1, reviews V3. 2.1 ops, 2.1 ops. Fairly equal. The latency between them is a little bit different. Why would that be? Well, because reviews V1 doesn't have any stars. It doesn't actually have to query the ratings service to get the stars. So you might expect it is a little bit quicker, and it looks like it is. On average, it's coming back about half as fast, or twice as fast. Okay, good. So I'm cognizant of the time. So we've got about 30 minutes left. So with what you all have been doing, with as far as we've gotten, you are well on your way and empowered to go through a number of different traffic management labs. Some of the ones that we would start on next are around resiliency and chaos engineering. I'm going to hit a couple of these very briefly and then see if we can't get over and look at Envoy filters, look at some Rust-based WebAssembly filters. And we'll talk about that product owner role that I was referring to before, how that works. Okay, so going into lab 6, we should, I believe we're going to want to, well, remove our virtual services, at least this last traffic split. A couple of ways you can do that. You can grab that definition, or even just this first part, this name, and go into Meshery. You can delete that custom configuration. So instead of playing it, you'll delete it, and it would remove it. You could go over and use kubectl to remove it. But if we look at what virtual services we have now, it's just the one Bookinfo. Good. Go back into our labs, go to lab 6, do fault injection and some rate limiting. The last lab that we'll do is some advanced rate limiting. So fault injection. If we, okay, let's start off by grabbing our traffic that's destined to the reviews service. Let's set all that traffic only to go to the subset 2, only to go to reviews V2. So we'll grab this, apply it. Just to verify, we'll be refreshing here. We should only be seeing black stars. That's the V2 version of reviews. Okay, great. Well, now let's mess with the traffic a bit. Let's inject some latency, some delay for HTTP packets. So it should be noted that there's, by default, Istio will configure, it will configure a global set of timeouts for a request, sort of end to end, at least, and so that is set to 10 seconds for Bookinfo. So if you make a request of the product page and it takes longer than 10 seconds for any of that to get a response, that default Envoy configuration will time out the request, and the user will get back, will get back a timeout. Okay, so if we can apply, we can get very specific about where we want to inject delay. In this case, we can inject delay not on the entire app itself, but maybe just on the reviews service. If you all can hear our rooster, I think he's a little late waking up this morning. Before we were so rudely interrupted, this is the V2 service of reviews, black stars. Let's apply a delay on retrieving those, but let's get specific and only apply that delay if the user that signed in has the name Jason. So let's grab this virtual service. This virtual service, we're going to name it reviews. Go apply this config. Go look at our, go look to see that we've got ratings reviews. And I'm gonna delete this reviews here. Oh, no, I'm sorry. Yeah, the reviews is to restrict everything to V2. V2 of reviews. And then now this ratings has that delay injected. Again, if we look over this and examine what's going on, is we're saying any traffic that's directed to the rating service, and that's the service that gives back stars, zeros, no stars, black stars, or red stars. We're saying that if the traffic is directed there, that's of interest. If it's of type HTTP, then what we're going to want to do is inject some fault. What type of fault? Well, delay fault, like latency. Let's inject some delay latency. For how long? Well, in a fixed way, let's for every packet, 100% of the time, let's inject 7 seconds of delay. Okay, but only for the user Jason, only if this user is signed in. Now, when this simple application, Bookinfo, it has cookies. And so you can make up any name that you want to and sign into the app. And that will be, that username will be included in the cookie. So right now we've applied our virtual service to inject delay. If we go back and look at our Bookinfo, we're refreshing, we're just getting back V2 here. If we go ahead and sign in as Jason, hit enter. Well, as soon as I hit enter, a request was sent to to product page, to Bookinfo. And immediately I'm having to sit here and wait 7 seconds for the response to come back. So, and the response did come back. I got a response back from product page and reviews, but I didn't get any data for ratings. So that rating service had 7 seconds of delay associated. And as such, eventually then that gets timed out. We get this message. Not good. So anyway, the example here is to really help understand that you can get extremely specific about how you want to manipulate traffic. For some, this is very helpful around chaos testing or just to understand the behavior of your different services and how they respond. But you can get much more. You can do some much more interesting things than this. Let's start looking at some of those. So this other one is let's update the rating service to now immediately send back an error code 500. Let's not inject delay. Let's do a different type of fault. This time, let's just, we will abort. We will immediately, 100% of the time, if Jason is signed, the user Jason is signed in, let's send back a fault immediately. So you don't have to sit here. If I refresh again, I have to sit here and can wait 7 seconds. And then finally the page loads. Instead, let's go ahead and load up this other config. So we'll apply this. This changes our ratings virtual service. Let's go back to the Bookinfo app. or refresh the page, and it comes back immediately. But it does come back with, under the covers, what's an HTTP 500 happening. Okay, interesting. Okay, with that, good. There's more labs to be done. There's one on circuit breaking. This is actually one of the areas where you really would want to use Meshery because of its load generation capabilities, so you can go break your circuit. The reason that we're skipping this is because I'd hope that we would get to this one, but it's because we want to talk about some of those advanced things around WebAssembly filters, Envoy filters, and how they're used. We're already actually looking at them and some of the telemetry that we're getting back through Grafana, through Prometheus. That telemetry is being generated through the mixerless telemetry filters that ship with Istio. A different concept to be aware of, though, is that of WebAssembly. So, so I guess we never got to take that break that I alluded to earlier. So hopefully all of your bladders are holding up. I apologize. It's just there's so much to talk about. WebAssembly is neither of the web necessarily or assembly strictly. So if this is probably a really bad way of introducing WebAssembly, but WebAssembly as a technology has been around for a little while. It's up and coming in the infrastructure space, in part because of some of the characteristics that it actually shares with Docker. Docker was popularized because of Docker made things portable, repeatable, smaller, faster. You would lose 10 pounds if you some great and interesting characteristics of Docker, and then cloud native came along, and here we are, and some of those same characteristics are seen inside of WebAssembly. So Docker was more secure. WebAssembly is as well. WebAssembly, a way of sort of again bastardizing the description of it is something of if you're familiar with the JVM for Java, the Java virtual machine, WebAssembly is also a virtual stack machine. So through WebAssembly, you're able to use it as a compilation target using about 40 different languages. You can compile to different targets. When you run a WebAssembly app, that runs inside of that virtual stack machine. And Envoy the work has been being done to build out support for a new application binary interface, an ABI, between to provide an interface between Envoy's capabilities, or a subset of Envoy's capabilities, and apps that are running in WebAssembly. There's a lot to pile into this description. So the Istio team had done an evaluation of what engine to use there as the WebAssembly engine. It's probably of no surprise that part of the same engine that gets the JavaScript V8 engine that gets used for Chrome is being used here in this initiative. There's, to draw that analogy again, I think to Docker, you could say that WebAssembly or WASM is becoming something of a write once, run anywhere. That was part of the same promise of a language like Java. So an interesting thing is you're able to, so why do you want to run this? Why are we talking about it? Well, one of the reasons is because there's a lot of things that you can do with those packets. We just looked at faults, injecting latency, and aborting packets. There's a lot more than you can do with them. You can rewrite them. You can get a lot more. If you're not getting enough telemetry, you can, out of the default filters, you can apply new filters. You can maybe convert traffic from HTTP to NATs, from one protocol to the next. You do want to optimize what you're doing. You do want to pay attention to how much that costs you. You'll have different costs in terms of just naturally, as you would expect, the more that you use something, the more that you'll incur some amount of overhead. So there's a trade-off to be aware of. Tools like the Service Mesh Performance Standard hopefully help with that, SMP. There have been some prior talks that we've given at well, the last few KubeCons talking about this and the importance of understanding what those trade-offs are and how much you're asking your service mesh to do, and whether you're running that functionality in your client library. Are you still running your retries there? Are you still doing some of your logic there, your infrastructure logic? Or are you handing it off just to the sidecar itself? Are you handing that off to the sidecar and maybe a WebAssembly filter? What's the difference and how are those get characterized? And there's, again, it was for another day, but there's some statistics and things published, so feel free to go look, to go watch some of those talks. Today, but better than that, what's probably nice, what we would rather do is get this into your hands so that you can go play with it and explore part of that power, and explore how a product owner can be enabled. One of those, so we wrote a sample application to do that. We called the sample application Image Hub. Actually, this sample app was demoed at DockerCon 2020 in advance of Docker Hub itself undergoing a policy change in terms of its subscription-based pricing, in terms of like not hosting the world's open file share for images anymore, for image storage inside of S3. And so if you're using Docker Hub today, depending upon whether or not your project is open source, depending upon whether or not you're a paying subscriber, you're authenticated or you're not, you're going to get a different response from the official Docker registry's APIs, from how many pull requests you can do per second. They're going to rate limit you. Right? Okay. Well, it's so we've been in conversation with the Docker Hub engineering team about how they're approaching that and how they're using what type of infrastructure they're running and how they can take advantage of the intelligence of a service mesh to kind of get there for free without having to change a lot of application logic in Docker Hub itself. So Image Hub is something of a ripoff of a generic, just a sample app that intentionally is a sample app that represents Docker Hub. Now this app has certain functionality written into it. It's just a simple app, it's 2 containers. And it has the ability to authenticate users and generate a token, as well as identify what subscription plan that user is on. But it doesn't have the ability to, it doesn't write in the infrastructure logic to rate limit users based on the plan that they're subscribed to, and how much their request, how frequently they're pulling, how many pull requests they have per second. Rather, it relies on the intelligence of the infrastructure underneath to do that. In this example, we used Console, because Console is also an Envoy-based data plane, a service mesh with an Envoy-based data plane to insert these filters. But that doesn't matter. We're using Istio here, and Istio's ability to do the same, to have Envoy filters dynamically loaded, and to have a bunch of intelligence happen in there, other than just things like telemetry or things like simple rate limiting, rather things like very specific application level or business logic level rate limiting happening based on who signed in and what subscription plan they're on. And this sample app lets you explore that. So on that note, I want for us to go through one last lab, and this is where I get to shut my yapper and let Abishek take us through this last lab. I left him all of 15 minutes, Abishek.
Thanks a lot, Lee. So will I be able to share my screen? I guess so.
Oh, and Pedro, let me see if I...
Oh yeah, I guess I can. So my screen is visible, correct?
Yes, it is.
All right. So like how Lee introduced you guys to the topic of WebAssembly, being at a very advanced concepts, and I understand that it's very difficult to grasp the or think about the abilities that any WebAssembly filters can do. Or it's always said that it's easier to watch and learn rather than reading it. So I'd want to demo that to show you guys a gist of what exactly what wasm filters are capable of. So I've got the Meshery dashboard in here. I hope the dashboard is visible. I've got my Istio installed. Is my terminal visible as well?
Your no, not that.
All right. In that case, let me just. I
Yes,
hope it's visible now.
it is.
Cool. So I've got my Istio installed in my cluster. I've watched for bots. Istio is already in there. Uh, I'm gonna. So I'm running Minikube right now, which would require you to run Minikube tunnel alongside, because you need to run the service type load balancer for Kubernetes. So yeah, having said that, let's start with the workshop. So the agenda of the workshop is that we deploy the image of application, and then we enable or we deploy a filter over the application to test out the rate limiting feature or the rate limiting capability of the filter by running a performance test over it. Uh, yeah, so let's get started. So in the Meshery dashboard, you've got this option in the manage sample application section, which would enable you to install image of application. So I'm installing it in the default namespace currently. So let me watch for that. As you can see, the containers are being created. There are currently two two containers that consist of the image of architecture. One is the web application itself, which consists of the UI, which is a dashboard for the application, and the API is the collection of APIs that serve the UI. As simple as that. Uh, as you can see, there is only one pod currently that is being one container that consists of this pod, which means that the sidecar is not injected. So I'm going to go ahead inject the sidecar first using Meshery here. If you look at the configuration, yeah, the automatic sidecar injection option would enable or would enforce a label in your namespace, which would uh, which would add a label to your namespace, which means whatever the applications in this namespace uh, you're deploying will be sidecar enabled by default. So I'm going to go ahead delete these two containers because these were created before we label the namespace. So now you can see the sidecars have been enabled in here. So let's go ahead and try to access these applications. In order to do that, we'll need to check what. So this is enabled. The sidecars are enabled in these applications. So it's behind the Istio Ingress gateway, and I know the Ingress gateway's IP from the Minikube tunnel. So I'm going to go ahead open it in a browser. So if you want to cross check what is the port that is running the Ingress gateway, the port that the Ingress gateway is listening to, it's the port 80 is mapped to 30823, and this basically would help Minikube users to get started. And yeah, so basically this is the IP and port in which I'll be accessing Imager, but also we'll need to add a host header. Basically what Lee demonstrated was by using a host entry, but I externally apply the host header, which implies that the host is being called. So when I go ahead open it, so the first thing to ensure is that we have the virtual service in place. There are two virtual services, and one of them is the web virtual service, which says that for this particular host, I'm going to forward all the requests by default to this particular application where. So that is in place. And apart from that, I need to. It's really bad. Okay. I'm going to take a step back here and say that I'm not able to. Oh, Lee, will you be able to demonstrate it? Probably I can explain it on from your screen.
Yeah, good question. We, given the time that we have left, probably best to field a few of the questions that are remaining. As a matter of fact, that's a call for questions to the extent that you've asked some, but they haven't been addressed. I'm going to put in a couple of resources that I'd mentioned before to make sure that you all are enabled with them. So this particular sample app, really interesting. It doesn't yet run what's behind Docker Hub, but we'll see where those conversations land and if it ultimately doesn't. So it could be really interesting for you all to check out. There's a collection of other WebAssembly based filters that you'll find in the ecosystem. There's also a couple at the links that I'm sharing in chat. So that's a link to the image hub itself, how that Rust filter is written, and how it looks up and references the, what user is signed in and what their what their subscription plan is.
Yeah, so basically I've got it up, and I swear I didn't change anything. All right. Yeah, basically sometimes it might take time instead of get stuff. So this is the image hub UI that basically has options of you signing up or login to the system, and also these are the available images in here which you can pull and use it. As Lee explained, this is almost a clone of or fork of Docker. So I'm going to go ahead and create a user, a sample user, which is subscribed to a team plan, let's say. And now I'm going to log in with it. Now, after I log in, I will be able to pull images out of it. And a funny thing about this is that you won't know. So to do a performance test, you'll need the user token, or you'll need to be enabled with you'll need to be logged in with the user to sort of pull images. So I'm going to go ahead and get my user cookie, which will be available in here in the authorization token. And now when I go to the Meshery dashboard to do a performance test over this, so right now we haven't enabled the online filter yet. And when we do a performance test, there shouldn't be any issues. I'm gonna go ahead with this part. Another thing I missed mentioning is that there is an endpoint called /pull, which is called when we click on this particular section here. So I'm going to go directly hit this API to test out my performance. So we can see that this particular API returns a 200 currently. And when we try to, so what we do is we first enable the filter, which is a rate limit filter, which does a 50 RPS rate limit currently on the team subscription. So in order to onboard a filter, I go to apply service mesh configuration and then basically say install on a filter. Now, when I do that, we'll need to watch for the default namespace. What it does is it patches the existing containers to enable the online filter and install it inside the Istio proxy containers. So once it has done it, I will go ahead and run the performance test to see what kind of how the rate limit filter behaves. So as you can see, the application container is running now, and we can still get the response from here. I'm going to go ahead and run the test. Istio with endpoint. And I'm going to give concurrent request, I don't know, 2. I'm going to bump up the QPS to, I don't know, 60 RPS for 15 seconds. We'll need to give it a couple of headers like before. The host header, which would be there will be the host header, which is imagehub.meshery.io. And the authorization header, which is what we got from the request headers. What is purpose? I'm going to run the test now, and let's see at what point it breaks. And as I said earlier, this particular subscription, the team subscription, handles 50 RPS, beyond which it rate limits. And so what we've got is no errors currently. So let's check out, or are we running out of time? So basically, this is how this is an example of how we just onboard a convoy filter to test out functionalities within your applications. Lee, do you want me to continue over here?
Yeah, no, thanks for this, Abishek. I think this introduces, I think accomplishes the mission of trying to introduce like an advanced concept about how it is that there's a lot of power in the data plane, and that through the ability to dynamically load envoy filters like this, you're able to, well, do a lot. I mean, you can offload application logic, application infrastructure logic. So with that, we're right on the hour. Any final questions from people? Any thoughts? I'll say this, that hey, feedback is especially critical feedback is always welcome. So reach out, connect, share the feedback, try out the labs, walk through the rest of them that we weren't able to get to. That's intentional, by the way. There's just a lot. Hopefully some minds were expanded just now with what Abishek was showing. Join the service mesh community. Each of the contributors in there are starved for feedback.